Good day, everyone. So for this day, we'll discuss about the application of elementary differential equations in a sliding motion down an inclined plane. So let's start. By the way, thank you for 310 subscribers. Sorry for the late uploads. Na busy lang. But each day magkakaroon na tayo ng mga uploads. Abangan. So let's now move on this figure. So there is a figure showing a weight W in pounds sliding down an inclined plane which makes an angle alpha with the horizontal. Assume that no force other than gravity is acting on the weight. There is no friction, no air resistance, and so on. At t is equal to 0, let x is equal to x sub 0. And let the initial velocity be at 0. Determine x for t time greater than 0. So ano ba yung sinasabi sa problem? So meron ka daw box. Ang force na nag-a-act lang sa kanya ay ang kanyang this one, weight. And syempre, since this is a box, ang movement niyan at naka-incline pa siya, ang movement niya is downwards. We all know that from your physics, weight is just the mass times the gravity. And you have this angle alpha. The technique here, para sa ating free body diagram, ang gagawin natin pag naka-incline, unahin muna natin gawin yung imaginary x and y plane. X is 1, this is x, this is y. Tara, balik lang natin. This is x and sorry, this is x and this is y. So, nasan kaya itong angle alpha na to in this box? So, idiretso natin to. Since dire-diretso yung weight na yan, pababa. Perpendicular to this plane sa x. And this x, this y-axis, pwede natin extend yan hanggang dito. Okay, nakabuo tayo ng isang right triangle. This is a right triangle. Okay? This right triangle is similar to this right triangle. Okay? This triangle, this one, if this is theta, what angle is this one? This angle is, okay, this is 90 minus the theta. Therefore, if this is the angle, and this angle, small angle, this is a right triangle. So if this is 90 minus theta, what angle is here? This is 90 minus 90 minus theta. Or this is just the theta. Okay? Sorry, this is 180 90 plus theta. So let's have an example. For example, this is 30 degrees. Angle here is 60 degrees. So this is a 90-degree angle. Therefore, this angle theta is also 30 degrees. So with that, we always say that the angle any angle, alpha, beta, theta, is just the same here. So this is your weight. So this is the force going down. This angle here is your theta. So if that is your theta, okay, creating this triangle, this theta is always equal to this theta. We have that weight. So the force acting on this weight is just summation of forces at x is equal to the weight times, so this is your coordinate plane. So this is W and this is your theta. Since ang pinag-uusapan natin is kailangan ay dito sa horizontal, this force horizontal at x. Therefore, this force is W. If andito yung angle, okay, makinig, no, this is very, very important. If nandito yung angle, this is simply F cosine. What angle is this? Halimbawa, this is theta. Eh, andito yung angle. Therefore, this is W. Diba dito? F. This is sine. F sine d alpha. Since this is W, gagamitin natin is W. W sine d alpha. We have that. Pero, ang ating F, so rewrite natin, F is equal to dW sine d alpha. Pero ang ating F daw is force is equal to the mass times the acceleration. We all know that this acceleration is equal to the derivative with respect of time, the derivative of the velocity. We all know that this velocity is just the derivative of the displacement with respect to t. This is the double derivative of acceleration papuntang from displacement to acceleration. We have that we all know that F is equal to W sine theta. We have F, this acceleration is just F is equal to this mass. Sorry, this mass is F is equal to F is equal to the mg, so mass times gravity sine theta. From here, F over m is equal to the acceleration. So we can divide these both sides by the mass. F over m is equal to the g sine d alpha. We all know that F over m is acceleration. We have acceleration is equal to g sine alpha. And we know that this acceleration is equal to this one. This t over dt times dx over dt equals g sine alpha. We can multiply it by dt. This will be d over dx dt is equal to g sine alpha dt. Next is let us now integrate both sides. G sine theta is a constant number here. So ilalabas natin siya. We have here the derivative of dx over dt. Tapos in-integrate mo siya. So mawawala itong derivative niyan. This is just dx over dt equal to, this is ilalabas mo yung g sin alpha. The derivative of dt. The derivative of dt is just this times t plus c1. This will be your equation number 1. Next, let us transpose dt here. So this is dx equals gt sin alpha plus c1. Multiply natin daw kay dt. This dt is equal to dx is equal to gt sin theta plus c1 then multiplied by dt. And then let's integrate both sides. Bakit po? Integrating both sides will give you determining x for t greater than 0. The derivative of x is just x. The integral of x is just, the integral of dx is just x equals, this is g. Ilabas natin yung sine, g sine alpha. This t, ang integral nito is t squared over 2. This is t squared over 2 plus c1 t plus c2. This is your equation number 2. Next, from there, ang equation 1 natin, sulat ulit natin. So that is dx over dt equals gt sin alpha plus c1. This is your equation 1. So your equation 2 is x is equal to g t squared over 2 sin alpha plus c1t plus c2. That is your equation number 2. So equation 1 natin at equation 1 equation 1. Ang equation 1 daw natin is kapag ang ti equal to 0, yung dx over dt daw natin ay velocity at first. Siyempre, ang initial velocity niya, this is at rest. Time is 0. Therefore, let's substitute that at equation 1. Dx over dt is the velocity O, or initial velocity. G times 0 is 0. Itong buong to, magiging 0 na yan dahil dito sa sinubstitute mo. And then, in just C1. Therefore, initial velocity is equal to C1. Meron ka na. Okay? Next naman, at equation 2, ang x mo raw ay kapag ang time mo ay 0, syempre, ang initial displacement mo is also x at any x. So, kahit sa may lagay, basta ang time ay 0. We have, let's substitute, x is x of 0 or initial displacement times, okay, cancel ulit to kasi this is 0 times g times sin theta. This is 0. Okay, next, we have this one, C1t times 0 to, this is 0 also. Therefore, this is C2. x of 0 or initial velocity is just equal to c2. Thus, we have this equation of any displacement determining x for any time greater than 0. This is x equals the gt squared over 2 sine alpha plus the initial velocity times time plus the initial displacement. And saan natin nakita to? Saan natin nakita tong equation na to? This is, kung natatandaan ninyo from your physics, that is itong x, treat natin siya as final velocity. Transpose natin itong x of 0, xf minus x of 0 is equal to gt squared over 2 the sine theta plus the initial t. This is change in x equals the gt squared sine alpha over 2 plus the initial velocity. Kung natandaan nyo yan, that is simply the change in x. Ito ang tatandaan ng formula, 1/2 the at squared plus the initial velocity times time. Ito yung mga nasa book. And that is the derivation kung saan nanggaling yung formula na ito. Next is we have to apply this sa ating problem. Thank you. And abangan nyo yung next problem natin. If nagustuhan nyo yung video, kindly like, subscribe, and ring nyo na rin yung bell for our upcoming videos. And also, huwag kakalimutan mag-subscribe. At nawa, marami kayong matutunan. Next is the application. Salamat!